So a new concept here, the concept of a function. Well, we've been working with linear functions. We were just calling them y equals mx plus b, things like that. But there are other types of functions. So like y equals some other formula, might be like the square root of x or something. Or we're going to get to also a function notation like f of x. So f of the function, it's basically the y value. So a couple things to get us started. What's this idea of a function? Well, let's start with something kind of simple. Like, what if you were looking at a menu and it says a slice of cheese pizza is $2 or $3? $2 or $3. Well, which one is it? Is it $2 or is it $3? You see, that's not very well defined. A function needs to be well defined. Like a menu would need to have, if I pick an item, what's the price? Okay? Not that a slice of cheese pizza is $2 or $3. That's not very well defined. This menu here, menu 1, this is a well-defined menu. It's a function. What's the cost of a cheese pizza or a slice of cheese pizza? $2. What's the cost of a pepperoni? $3. What about the veggie supreme? $3. Yes, that would be a function. It is clearly defined. Every item has a definite price. Whereas this menu 2, we're running into that issue again. Wait a second, cheese, is it $2 or is it $3? It's not very well defined. You can't say what's the cost of a slice of cheese pizza. That is not a function, okay? So notice it's okay on like this first one where you have two different items that have the same price. That's not a problem. But you can't have an item that has two different prices. That would not be a function. So a formal definition of a function would be in which the two ordered pairs, none have the same first coordinate. In other words, the x coordinate is only paired with one exact y coordinate. So the independent inputs are the first coordinate. That's called the domain. That would be your x's when we get into the variables. And then the outputs, right? The formula is based on x. So y is calculated. It depends on what the value of x is. Those y's would be your range. So graphically, we can look at visually like, oh, wait a second. Look, this first one, there's an x coordinate, right? But that has two different y coordinates, right? This would be like, say, if I give those values, let's call that 1, 1, -1 there, right? Here you would have 1, 1, and 1, -1. That would be a problem because I have two ordered pairs that have the same first coordinate. And also you could say that this fails the vertical line test. If you have a graph that you draw a vertical line, if that vertical line hits the graph 2 times, not a function. All right. If I look at the next one, if I start looking at the vertical lines, oh, look, that vertical line only hits it once. That vertical line only hits it once. Any vertical line I draw only hits the graph one single time. Every x coordinate has a definite output, one single output. Whereas over here, again, I kind of highlighted that in red, I have an x coordinate that has two different outputs, not a function. The one on the right, example B, is a function. All right, so you'll see some problems based on that in the homework. And then the other part of this is just function notation. We've already seen this. You plug in the values to the formula. This says f of x. F of x equals x squared plus 2x. Okay, so in other words, we're going to plug in the x value to the formula and do the calculation. So for f of 3, that means x is 3. So I plug in those places where the x's were, but now I'm plugging in 3. So 3 squared is 9, plus 6 gives you 15. So f of 3 equals 15. Let's do another one where we do f of negative 2. Now you got to watch your signs there because negative 2 is in parentheses, giving you a square of positive 4. Remember, a negative times a negative. And then, let's see, 2 times negative 2 would be negative 4. So that gives us 0. So in other words, f of negative 2 is 0. And then so if you were going to plot these on a graph, we have the ordered pairs, x, y. Well, y is your f of x. It's the same kind of output, okay? So the f of x, the calculation, remember the x was 3. The output of that, or your y, is 15. On the other one, your x was negative 2, and it has an output, or an f of x, of 0.